Okay. Example 5. So we're going to go back to cupcakes. So we'll have the same 3 base flavors. Right, so we're going to have the vanilla, chocolate, and the one that I don't really understand, strawberry. But now what we're going to have is we're going to have 8 different toppings. So we're going to have 8 different toppings. But we're going to have exactly one of each topping, right? So we're going to have, I don't know, we'll say like 1 peanut and 1 sprinkle and 1 gummy bear. And I can't really think of toppings, but the point is there's going to be 8 of them. So we have 3 base flavors and we have 8 unique different toppings. Now we're going to continue the problem. The toppings are stacked carefully. The toppings are stacked. It matters which is on top. So for example, if we have peanut and sprinkle, that would be different than sprinkle and peanut. Okay, I'm not an artist, but peanut sprinkle different than peanut. So sprinkle on top of peanut is different than peanut on top of sprinkle. So these things are not equal to each other. And then the last rule is going to be that the cupcakes can have 2 or 3 toppings. And so the question is, of course, how many different cupcakes are possible? So you could pause the video right now and try to figure it out yourself. I assume you paused it. And you have an answer. So let's get the answers. So what we're going to have here is we're going to have something called cases. We're going to do this in cases. So what the cases are, so first we could say is, so this is going to be done in cases. So what we could have is we could have, for example, no, we can definitely not have 1 topping, we could have a 2 topping cupcake. So a 2 topping cupcake is going to have, it's going to have a base flavor, it's going to have the first topping, and it's going to have the second topping. And we know that there are 3 options for the base. There are 8 options for the first topping, and this is one of those decreasing ones because once we use it up, it's gone. And so that means there's only 7 options for that topping. So that's going to be a total of, we're going to multiply these guys. So it's going to be 3 times 8 times 7 is 168. So we're going to have 168 possible cupcakes. So 168 different 2 topping cupcakes. Okay, now let's say it was a 3 topping cupcake. So that's the first case. Now the second case is going to be a 3 topping cupcake. And a 3 topping cupcake is going to be pretty much the same. We're going to have our base, the first topping, the second topping, and the third topping. And we're going to have 3 times 8 times 7, and then we've used up these 2, so it's going to be times 6. Dun, 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 dun. And that's going to be times 6 is going to be 1,008. So there's 168 2-topping cupcakes. There are 1,008 3-topping cupcakes. And so how many cupcakes are there in total? Well, what we're going to do when we have cases is we're going to add them up. So it's going to be the 2-topping cupcakes plus the 3-topping cupcakes. We add them up, so it's going to be 168 plus 1,008, and that's going to give us 1,176. And that would be the answer. There's 1,176 2 or 3-topping cupcakes. Let's say I change the rule slightly. So let's say, we'll call it a part B. So let's say in my part B I say, can have repeat toppings. I can't spell repeat. Can have repeat toppings. So if we can have repeat toppings, then the 2-topping cupcake, so we have our 2-topping and 3-topping cupcakes. That's going to be base, first, second, base, first, second, and third. We're going to have 3, 8, but here we're not losing a topping. Once we have a topping, we can have it again, so we have 8 options for this one as well. And this one would be 3 for the base, 8, 8, and still 8 because there's nothing wrong with that, so it'd be 3 times 8 times 8, 3 times 8 times 8 times 8, which would be equal to, so 3 times 8 times 8 is, 64 times 3 is 192. And this one would be 1536. And it's cases, so we're going to add them together. So total is going to be 192 plus 1536, which is 1,728. So if we're allowed to repeat the toppings, it's 1,728 toppings. Okay, let's do part C. So part C is going to be, can repeat toppings but cannot have 2 of the same next to each other. Because really that would be a little bit lame. So we can repeat the toppings but cannot have 2 of the same next to each other. So we're going to have again our 2-topping and our 3-topping. So our base, first, second, base, first, second, third. Oops, I'm kind of out of space here. Again, I would pause the video, see if you can figure it out yourself. Let's presume you have an answer. So with the base over here, there's 3 options. And then for the first topping, we have 8. This can't be the same as that one, so this is going to be the same as the other one. So this is just going to be, we already knew this one. This one's 168. Nothing very exciting about that. Here we have 3, we have 8. This one can't be the same as that, so it's 7. And this third one, it can't be the same as that, but it could be the same as this one over here. So actually we would still have 7 options, right? So for example, if it was, say, this was sprinkle, this one could not be sprinkle, this could be the nut over here, and this one cannot be nut, but it could be sprinkle again, so there's still 7 options. So that would be 3 times 8 times 7 times 7, 3 times 8 times 49, which is going to be 1176, and if we add them up, because it's cases, we get a total of 1,344. And there you go.